Let's solve a squared is greater than or equals to 4. When we take the square root of both sides, we could think plus minus 2. The square root of 4 is plus minus 2. Now draw a number line, and we're thinking about either positive 2 or negative 2. Previously, when we have a question like a squared is less than 4, we focus on the domain being between these two values. However, when it's greater than or equals to 4, we're going to focus on away from these two numbers. So this is towards negative infinity, and heading towards the right, we're heading towards positive infinity. So the answer is a is less than or equals to negative 2. We copy the equal sign because it's in the question up here, or a is greater than or equals to 2. Let's try a similar question. Let's solve x squared is greater than 7. We take the square root of both sides and we have the critical points plus minus root 7. And when we draw a number line, have a hollow circle at root 7 and a hollow circle at negative root 7. And the solution region is towards the right or to the left. So we say that x is less than negative root 7 or x is greater than root 7. Let's understand this inequality a bit more visually. We have a squared minus 4 as we throw this number 4 to the left. And this happens to be greater than or equals to 0. What is the meaning of a graph being y equals a squared minus 4 or x squared minus 4? It's a parabola shifted down 4 units with x-intercepts either 2 or negative 2. And for the parabola to be greater or equal to 0, we're talking about equal to 0 being sea level or greater than. We're interested in the domain in which the boat is above the water. It's above the water towards the left and towards the right. So indeed, a is less than or equals to negative 2, or a is greater than or equals to 2. Let's solve this quadratic inequality using set notation. So the key is we're going to use inequality symbols that look like alligator brackets. Let's factor this trinomial. We have x, minus 2, and minus 3. Negative 2 times negative 3 is positive 6, and these numbers add to be negative 5. And we get the quadratic is less than or equals to 0. So when we sketch this parabola, we have the critical points at the opposite of negative 2, which is positive 2 to the right here, and the opposite of negative 3 is positive 3, which is over here. So we draw a parabola that cuts through these two x-intercepts. And the question we're asking is, when is the parabola less than or equal to 0? When is the y value below the x-axis? It is true between 2 and 3. Within this domain, looking side to side, this parabola is underwater. So we say that x is between 2 and 3, including the endpoints. Now using interval notation, this domain is equivalent to square bracket 2 comma 3. X belongs, this looks like a C with a line going across, between 2 and 3, including the endpoints. If this bracket was rounded, it would mean not including the endpoints. If we wrote 2 is less than x is less than 3, x belongs between 2 and 3. But this is not the case. We are including the endpoints. Finally, if we want to use a number line, we could. We focus on the critical points 3 and 2. And x, the domain is between these two numbers. So we shade in all these values, including the endpoints, between 2 and 3. Towards the right, we have positive infinity, and towards the left, we have negative infinity. But the solution region is only between 2 and 3, including the endpoints. If we weren't including the endpoints, we'd make these points hollow circles instead of solid ones.